Thanks, Sean. Thanks, Betty. So I think, Sean, in terms of who I am, I think Sean covered it off there. So Anton Whalley, based in Dublin. My contact details are at the bottom of the slide there. You can contact me at IBM, and you can also get me on Twitter as well. I do hang out on most social media. Okay, so to jump straight in, I guess, what I'd like to do is sort of start at the very top, sort of give you a view, sort of what's IBM about, just in case you haven't heard of IBM or you don't quite know how we fit into the sort of cloud market, give you that point of view. Then mention a little bit about the RedHat acquisition, sort of how that's playing into IBM's strategy, and then dive straight. Won't spend too long on that, but then dive straight into the sort of serverless aspects of our stack. Okay, so to just get focused on the screen. Okay, so very quickly then, IBM's cloud point of view. So we see cloud as a hybrid, multi-cloud, open and secure and management arena. Okay, so what do we mean by hybrid? So in real term, the reality is that only 20% of workload has made it onto public cloud infrastructure. There's still 80% of the world's compute workload that's still being executed on premise. And there's people, certainly public cloud providers, are trying to accelerate the move to public cloud infrastructure. But we're seeing that the several industries are struggling with that. And there's a lot of reasons for it. There can be regulatory, there can be skills, and there can be a lack of process sort of reformation. So the way that we're seeing sort of public cloud adoption is we see it as a decades thing. It's not something that you're going to necessarily execute all at once within 2 years. So IBM, and particularly with our customers, we're sort of helping them get to cloud, but we're helping them do it at their pace. Okay, so multi-cloud, lots of our customers are deploying onto multiple clouds, AWS, and we see SaaS consumption, etc., etc. And then I think the critical piece of what we're talking about today is the open. So obviously IBM made the largest software acquisition almost a year ago now. So yeah, the acquisition of RedHat, I think that's testament to how much sort of IBM believe in open source technology and believe that that's where the innovation is really coming from in terms of new ideas that we can share, not just between vendors, but between the commons as well. So between organizations, between individuals that want to pick up and understand IT. Open source has definitely changed the whole compute landscape over the past 20 years. Okay, so that's sort of how IBM differentiates. Again, we're not just about pushing people to public cloud, we're about bringing cloud to you. And then I mentioned RedHat there. So RedHat is giving us the foundation that acts as an abstraction across all the different deployment targets. So what do I mean by that? So at the bottom, we have infrastructure providers. So we have IBM Cloud, we have AWS, we have Azure, Google, we have edge systems, we have private clouds, we have mainframes, etc., etc. And what we're doing in with RedHat is we're using Linux and Kubernetes as an infrastructure or an abstraction layer across all these different deployment targets. Okay, and then on top of that, we are deploying our open source capabilities, some of our AI capabilities, etc., etc. But that's really the pattern that we're going to use to enable what I mentioned previously, which is sort of hybrid cloud and multi-cloud strategies. And I think the fact that RedHat is a separate organization from IBM, they have their own relationships with all the providers that I mentioned below. I think it's a good strategy to enable this single abstraction across the cloud. Okay, so that's enough sort of the architecture, sort of top level stuff. Let's sort of dive into the specifics here. So what do I mean by enterprise serverless? So enterprise serverless, I really see it as a composition of these three aspects. So what we're seeing there on the left hand side, the CNCF's definition of serverless. So it needs to be scaled to 0. It needs to be auto-scale. It needs to be able to auto-scale. You need automatic routing, event triggering, and per-use consumption. And they're sort of the de facto, every serverless implementation, be it in public cloud, be it on-prem, wherever you're running it, it's got to have those attributes. I also think as well as the CNCF definition, or developers definitely see it as a server configuration development scenario. They don't, the developers using serverless don't want to have to be thinking about how they configure upstream infrastructure or whatever they're deploying onto. The flow for them has to be as seamless from the desktop to the production deploy, okay? And that's got to be as quick as possible. And you also need the ability not to be able to bring your own tools and libraries into that workflow as well. So you can't wait on providers necessarily to release packs or implementations of a serverless environment for you to go and consume. If you want to go and write something in the latest form of Python, or you want to use the latest Node runtime for whatever reason, or you want to build your own Node.js runtime, you want to go and deploy that into a serverless workflow, you should have the opportunity to do that and not have to wait for somebody else to go and run it for, to go and build and deploy that for you into a serverless environment. And then, so strictly then on enterprise, where enterprise is the usual sort of factors: security, integration, and by integration I mean it's got to fit in whatever serverless technology you're using. It's got to fit into the current enterprise technology landscape. So in enterprises, while developers will be can bring in new tooling, sort of the running and the operation of it into standard workflows that are already in place, that has to be feasible. And again, that's something that using sort of Red Hat based technology and OpenShift, it sort of simplifies that scenario quite quickly. Okay, and the other aspect that enterprise customers want is, or enterprises want, should I say, is a roadmap. Sort of what are we thinking of in terms of what's the direction for this in 3 years? What happens if we invest in this now? Where am I going to be in 8 years? Are you going to retire it? What support structures do you have in there? And these are sort of the extra concerns that you get in an enterprise scenario that sort of differs from sort of cloud native or born on cloud type constraints. Okay. So, and then, so what are the challenges that within those constraints that you have? So enterprise see Kubernetes and serverless as rapidly evolving technology landscape, and they basically want help building out this microservice containers and open source. They need to get support in the way that that's bundled up and the way that they consume that. There's, from my engagements that I've had with, certainly in the Node.js ecosystem, bringing serverless type technology and rapid application development type technology into organizations, there's a huge dark matter development within enterprise organizations. They like their tooling that they've been using for almost a decade. They like their application servers, and they find changing from that workflow into new workflows quite challenging. So if you're going to bring serverless type technology into an organization where there's people that wouldn't be as keen to accelerate into new technology, you've got to bring a path to them that helps them on board, okay? And again, sort of I mentioned previously, sort of the enterprise grade requirements, so the security, the day two operations as well, sort of how are you going to run this once you built whatever you're going to be building, how are you going to build that, how are you going to deploy that, how are you going to look after feed and water it later, after, like I say, after the development's done. What we built is a technology called Apsody, and it's a development and deployment, it's an open source development and deployment framework that allows enterprise architects to build predefined stacks that can be used within the development process and managed through a single user interface, and use those stacks. Then those stacks are then bundled and then deployed into a Knative or a Kubernetes environment. Okay, so that's the specific piece of technology that we're going to be talking about, and sort of how does that map then to the different roles that you see within an organization. Okay, so we see Champ here. Champ's a solution architect. He needs to be able to sort of take the best of breed open source, validate it, and create these stacks and bundles. And we have stacks defined for Spring Boot. We've got them for Spring Cloud. We've got Open Liberty. We've got Node. We've got Swift in there. We've got Python coming through. We also have some Rust stacks as well. But anyway, the main thing is that Champ puts these stacks together and they're predefined, and Jane can then pick those up and use them from a command line and deploy them in a serverless fashion. Okay, so she uses Apsody, and we'll step through this in the demo, but she basically uses Apsody to select one of these packs, do some development on it, run test, and then deploy into a Red Hat OpenShift environment with Knative installed. So that's really what we're talking about here, okay? So let's have a look at that. So if I escape my screen here. We log in. Okay, so I've already been doing a couple of demos here. So what I'm going to do now is take on the persona of Jane. I'm probably not as good a developer as Jane is, but I'll give it my best shot. So if we go, all I'm going to do here is create a directory. I'm going to call it function. Okay, and this is going to be my project. So I'm going to cd into a function. And the first thing I'm going to do as a developer is I want to list the projects that I have available to me. So what projects are around that I can select. So which I'll just minus down for a second. There we go. Okay, so you can see of the projects that are available. I mentioned you've got Rust, I've got the versions of them, and we've got this sort of gated, local, experimental, or incubator level projects, and I've got them for all the different technology stacks. And what I'm going to do here is, so I'm a Node.js developer. I want to we have a few flavors of Node.js within this stack. I've got a predefined loopback stack for building out APIs or enterprise level APIs, but I just want to write a quick Node.js function and host it within a container. So I'm just going to do Apsody init and experimental and Node.js functions. Okay, so that is initializing a project, and we'll have a look at what this is sort of in a few minutes. But from a developer's point of view, if I actually open code in this project now, we can see that what's been generated is a Node.js project with your standard sort of npm package.json. And within there, I've got a very simple module that I'm going to export. So I can define the URL or the endpoint that my function is going to live on, and I can export the get, post, etc., from this individual file. Okay. So what you'll notice is that I'm not carrying any of the server infrastructure of the Node.js application within this development environment. I'm just carrying the function. I edit the function, and what's going to happen in the background is when I run this, it's going to go off and find a Node.js server, an express Node.js server, inject this function into that server, and it will serve up hello Apsody for me. Okay, so let's just have a look at that. So if I go Apsody run, as I mentioned, it goes off. It finds a Docker container, and it goes and builds my package and marries that into the predefined Docker container. So if npm's kind to me, it shouldn't take too long. Okay, so now we're up and running. Sorry. There we go. Now we're up and running. Okay. So I can, on my local machine now, that's done, automatically done, all the port mapping and all the sort of tricky Docker things that you need to do. So the developer doesn't have to think about that, or Jane doesn't have to think about that. She can now just go to localhost 3000 and hello Apsody is served from there. Okay, so that's sort of what we mean by enabling a rapid application development environment. When I work with developers that are just using Docker. Sort of managing the exposing of the development environment and getting that ready on a developer's machine is quite tricky. So what we're doing with Apsody is just abstracting that away and just getting that up and running as quickly as possible. Okay. So then within this, it's also set up a real-time watch for me, so I can go whatever serverless Dublin. Okay. So I can edit that, save it. It automatically goes away. I've got an automatic watch, so it's watching my local file system. It's seen that I made a change, so it's automatically rebuilt it and exposed it again on port 3000. Okay, so if I dive back into this, I can run, and I've automatically got that on within my environment. Okay, so that's like a really sort of quick feedback. Of course, you need to be able to debug as well. So I'll just stop the run there. What I'll do in here is open up a terminal. So I'm in Visual Studio Code, but you also get this functionality in Chi as well, so or Eclipse. So I can go Apsody debug in here. That'll do something. It'll run an initial build, but it'll run the build in debug mode. And once that's built for me, I'll be able to step through code as you would expect to be able to do within any sort of development environment as well. Okay. So setting up local development within serverless has traditionally been quite a tricky thing, but we think this sort of captures it quite well. Okay. So if I set a breakpoint in here, I should be able to go to this, and I should press refresh. Oh, sorry, I need to debug first. So if I go start debugging here, I set it up, my Visual Code goes into debug mode. And now when I press refresh, it should jump me into my debug, and I can do all the usual things that I expect to be able to do, inspect objects, etc., etc., etc. Okay, so that's the sort of debugging lifecycle, or sorry, development lifecycle that we have. Okay, so I've got this up and running on my desktop. I've got it saying exactly what I want it to do, which is serverless Dublin. How do I get that out onto the into the infrastructure? Okay, so I've already logged into my OpenShift cluster, but I'd log into my OpenShift cluster, and then I can run a set of commands that will basically deploy this for me. Where have I gone? So so first thing I need to do from that is create a build. So what I'm going to do is create a build of what I have. So I've been running it in debug mode. I've been running it in run mode. I also have a build or a production version of this that I want to get out there. So let me just stop this to make sure we don't get any clashes. Okay, so I should be able to go Apsody. Oh. Okay, I'm going to give this a tag. So this is a Docker tag, and my Docker handle is number 9, and I'm going to call this a function and give it a. And I want to push it straight away to the Docker repository. And I also want to make it Knative enabled as well. All right. So when I run this, it'll go off, like I say, it'll run the build. And then in the background, what's happening is it's generating in the project. If we jump back into the project code, we will see when it's finished the build, it'll generate a Kubernetes deploy config. We'll just have a look at that before we push it there. So let's have a look at the chat while that's building. Yeah. Okay. So there's a question around OpenWhisk or Open Functions as a Service versus serverless on IBM. It's a good question. I'm actually going to defer that till the end because there is a difference between sort of what I'm talking about here in terms of function as a running Knative and a local development deploying into Knative against a a cloud provider's function as a service. All right. Okay, so that's created my deployment. Let's push my container to Docker, and it's created my deployment manifest. Okay, so within my deployment, it has some descriptions around the serverless stack that I've used, and it has some additional information around what my application image is, but the key thing is that it's got this flag which is create as a Knative service. So this Docker container that I've constructed, it can be run as a traditional container, or it can be run as a Knative service. So obviously I'm going to run it as a Knative service because I want it to be as low resources, use as little resources as possible. All right. So now I have that, and I have my artifact. What I do is I can, usually this would obviously be ran through a CI/CD type pipeline, but if I'm doing some dev test and just need to do some integration tests, so I need to get it onto a dev environment, straight from Rhapsody, I can deploy this into my OpenShift, my Kubernetes cluster, okay? So I don't want to build it again. And I do want to deploy it as a Knative, okay? So as you can see, this has deployed this to a public endpoint in my OpenShift cluster, and I've intentionally not shown anybody in the OpenShift cluster or any sort of backend infrastructure, because I just wanted to get across sort of what the developer flow is for this. You don't need to worry about where you're publishing to. It is very, very much a serverless workflow. So if we now go into this, we see I've now deployed into a function into a public endpoint on IBM Cloud, okay? So in terms of what's happening in the back, within, this is I'm on IBM Cloud here, so this is the IBM Cloud console. And within there, I provisioned an OpenShift environment. So, and within that, I've used the OpenShift operators. So within OpenShift, you have this idea of operators, which is pre-packaged, pre-configured software that you can deploy within your OpenShift environment. And I've installed the OpenShift serverless operator. So there's a set of 5 or 6 steps that you need to go through in order to provision this to make your Kubernetes cluster Knative, and deploy the OpenShift operator on there. Okay, and when I deploy this operator in, it extends the functionality on the left-hand side with Knative functionality. So I can see serverless. I have the serverless definition. I can see my A-function app has been deployed, and as a service, as a Knative service. It shows me the URL there, and I can also have an overview of what that is, what properties it has associated with it, and the YAML deployed, etc., etc. Okay, so that's sort of a very, very quick view of what's happening on the back end. I'm sort of looking at time a little bit here, so I'm just on 6 o'clock. So it's going okay. I think in terms of what I want to show you there, I think that's it. So hopefully you can sort of, I've intentionally been light on the back end architecture here. What I really wanted to get across is this OpenShift, because of what IBM are doing with OpenShift and with Red Hat, you can deploy OpenShift wherever you want. You can deploy it on-prem, you can deploy it in public cloud, you can deploy it at the edge, doesn't matter. And once you've got OpenShift up and running, you can bring serverless functions with you. So again, as I mentioned, serverless is part of the cloud native tool continuum. Okay, so what does that mean? I don't see things or applications moving from moving from the mainframe into VMs, into containers, and into OpenShift. It isn't a destination. It's just another tool that you can have as part of your cloud stack, that can help accelerate certain problems within software development lifecycle. What we have is something that makes serverless technology available to the wider organization. So the benefits of serverless and using and thinking about compute resources, traditionally it's only been given to the digital teams that are deploying onto public cloud infrastructure. And that's problematic within organizations, because that's not necessarily that's not the only place where you need speed, and it can create a sort of us and them divide within organizations. And what you need to be thinking about is as you think about serverless and adopting serverless within your organization, is how are you going to drive that technology throughout your different teams. Okay. Again, I'd be very cautious, and serverless actually fits into this really well. So when you're adopting new technology, look at your KPIs, look at your business drivers when you're evaluating tech. So is it actually giving you the increase in deployment that you expect it to give you? Is it actually cutting down on the amount of resources that you're using when you deploy a project, et cetera, et cetera? Because if it isn't giving you those type of business benefits, then you may want to evaluate using it. Because while it's a lot simpler for developers from an operations point of view, it does have a significant overhead, as any new technology. That's just not specific to serverless. Okay. And again, while developer experience is important, we don't want to sacrifice day two operations. So the fact that the serverless platform that we're presenting is built on an open source stack, Red Hat technology is in every organization that I speak to has Red Hat technology. It's something that builds on top of that investment that's already been made by the operations folks. It's a lot better story than bringing in a whole heap of new from somewhere else and deploying that within the traditional infrastructure. All right. And then finally, I guess, we'll publish these slides at the end. These are links to sort of tutorials, sort of what we've been through here, sort of an accelerated run through that, sort of what the CNCF definition of serverless is, getting some OpenShift on IBM Cloud, and the installation instructions for installing Knative. And then we've got a very new announcement this week around Knative on IBM Cloud. So we've got as well as being able to deploy into OpenShift, you can also deploy OpenShift and then install Knative into OpenShift. IBM Cloud also offers that as a pre-packaged deployment as well. That's brand new out this week. So I don't want to dive into that too much, but it's definitely something that some folks would be interested in. And that is all I had for today. Hopefully it wasn't too fast and it made some sense and it was interesting to some folks, but happy to take questions.
Good man, thanks very much for that, Anton. Definitely informative, and it's good to see a live demo that went well without any hiccups. They don't usually happen, so fair play to you. I had a quick one there. Obviously, I think there was one question that came through from Lalith there. He was just quickly asking about how kind of open functions as a service and OpenWhisk, how they kind of integrate as well. I think you mentioned you did want to follow up on that, so I don't know if you kind of want to give it a bit more airtime now.
Yeah. So OpenWhisk was our first iteration as functions as a service. So we built it as an open source project, but it was delivered by our, it was delivered on our public cloud platform. And what it wasn't particularly good at was being deployed into an on-prem environment. It didn't really suit that scenario, the scenario that I've just stepped through here. In terms of developer functionality, it feels very similar. It's a command line, you create a project, you deploy that project, etc., etc. But it's very much in terms of the difference between them is where can you consume OpenWhisk? You can only get that from IBM Cloud. Similar to as Lambda on AWS. Where can you get Lambda? You can only ever get it on AWS, right? And what I'm saying is that as only 20% of the code being deployed is being deployed into AWS or being deployed into public cloud, like we've got to bring functions as a service and serverless to folks who work inside the data center, and that's why that's the primary difference between what we have. One's a proprietary technology stack, although OpenWhisk isn't. It's an open source one, but it's very much standalone. Whereas what we're looking at here is Knative, Kubernetes, so serverless on Kubernetes, built with open source technology.
Right.
Okay.
Those were the things that I kind of want to pick up on Knative. Obviously, it's kind of still in its infancy, to put it lightly. In technology terms, it's not overly built out just yet. And sure, even IBM this week, as you kind of said, with new functionalities and that. One of the things that I kind of was curious to see is there a risk of committing to Knative as either a large organization, and given the fact that it is open source, with cloud vendors not supporting it and not kind of going down that route, is that something that you'd be wary of, or is it something that you could definitely see kind of taking over the market essentially and becoming a staple within tech stack over the next level?
Okay, so I guess I've got two things there, and it's the first one is taking over the market. Okay, So one of the benefits that we're seeing with open source and what it's teaching all the multinationals, et cetera, is that we live in a community now, okay? This is not about global domination that we saw in the 90s, sort of one operating system, one web browser. We've seen how toxic that is to the delivery of IT solutions, okay? When you have a dominant in the market, it stagnates. Like Internet Explorer didn't change. I'm sorry, I don't know me to pick on Microsoft, but it is a really good example. Like we struggled with bringing technology like Ajax, like enhanced JavaScript into the browser, because once Internet Explorer became dominant, that was it. Innovation died, okay? So we definitely got to build ecosystems that push, that try and fight against that as much as we possibly can, okay? So why am I saying that? Because we're definitely not positioning Knative as a winner takes all. If you're not doing Knative, you're not doing serverless. There's nothing wrong with using OpenRest. There's absolutely nothing wrong with using Lambda. If it works for you and your scenario is within one vendor, within AWS, and that's working, that's fine. Where we're coming from is that's only in AWS, and that's not where the compute is. The compute is all over the place. What happens if you want a consistent approach across all the different places you want to do it?
Okay, perfect. I think Peter has just dropped a good one in here into the chat. I don't know if you want to take a look at it there, just so I don't watch this. Is the premise here that these functions only handle a single URL, for example, or they can use more URLs for a single function?
So yeah, in the background, Peter, ultimately what you're doing is and I know Peter's pretty reasonable with Node.js. So basically, although I didn't ask him to ask this question, by the way. So
no plugs.
this isn't a plug. So basically what's happening there is it's marrying the file of functions that you create. So let's actually just open this up so we can see some code rather than just wobbling my hands. Yeah, here we go. Okay. So really, it's taking that file of routes that are defined in here, and you can export them. Okay, so right now it's explicitly exporting get. Okay, but if you want, and you can post, etc., etc. But if you wanted to, because this is all open source, and you can go to where this is defined in here, you can modify the way that marrying between the definition and the application and the node server happens. So if you wanted this for whatever reason to contain lots of gets or lots of posts with lots of different routes, you could go and do that. It's got that type of flexibility in it. What this is a reference implementation of how you do one, and if you want to go and sort of take that wherever you want, you can do as well.
Perfect.
So,
I think,
yeah,
good stuff. Nearly answered Ram and Deep. I think we've got time for one more before moving on to Shane. It's from has to be, I hope I pronounced the name correctly there. Is a Knative component that brings the serverless feature to OpenShift.
Sorry, where are we looking here now?
In the Q&A section, sorry.
Oh, there's always one that goes where they should do.
Look, some people listen, others don't. Yeah, there it goes.
Yes, yeah, absolutely. Knative is the technology that's bringing serverless to OpenShift. Yes.
Perfect.
Yeah.
Perfect.
And apologies, I didn't want to dive into that level of the architecture. I did want to keep it as a developer flow, but yeah. Okay.
I've got one more, but I'll save that for later for the panel's discussion.
Yeah,
I'll hold off. Perfect. Listen, thanks very much for that, Anton. We'll probably catch up in about half an hour or so.